Oh, well, greetings everyone. It's Peter Mikula here from Mikula Geotechnics. I'm very glad to be here to be able to present this information to you. And I've given it the topic, do you remember these geotechnical incidents in our mine? It's in inverted commas because I couldn't help it but include some borderline geotechnical incidents, as we'll see. I'd like to start by quoting words from my mentor, that's Max Lee, way back when I first joined Mount Charlotte. If you don't jump when the workings shake, it's time to quit. We were walking underground in one of the drives, and definitely the ground shook, and I went up with a start and tried to run, and Max said, "Well done, you qualify, you can actually be here." So that was my introduction to major seismicity. Now, I wonder how many of us woke up at 3:15 this morning in Kalgoorlie. There was a geotechnical incident, turned out to be a quake. I recorded it on the regional seismic network. Unfortunately, only one sensor is operating now, and that's at my house. And the first recording I got is shown there. It came in at a Richter 3, depth about 1.7 K, and its location is somewhere on this circle here, but we didn't know quite where. I got in touch with a couple of Kundana mines. No, nothing happened over there. Got in touch with Mount Charlotte. No, nothing happened there. So where was it? So I investigated a bit further, and I adjusted the waveform slightly. And now you'll see that by moving the P-pick from here to here, which seemed to be a fairly logical way to go, the circle changed a bit and went through South Kalgoorlie. I've been contacted by quite a number of people who talk about severe shaking. It sounded like, for example, a truckload of bricks being unloaded on the roof of my house, and a short, sharp crack with a rumble in the distance and things like that. So we certainly had a quake somewhere in the South Kalgoorlie or Boulder area. Just want to show a couple of slides from the presentation I gave at the previous WA Ground Control Room meeting in Kalgoorlie. There's now only one RSN, Regional Seismic Network node, still functioning, and it's fallen on hard times. However, these days we've actually got the Raspberry Pi machine, and it's got an extra card inside that does the digitizing, so it's quite easy to actually have your own seismic sensor at your home, which is what I have. So a year or so ago I was calling for people who might be interested, and it's cheap. Your mine only has to fund $150 to buy the equipment, and you can probably have your own sensor. There's an advantage of it. You can correlate local magnitude and Richter magnitude, the local magnitude from your seismic system, and compare it with the government Geoscience Australia Richter magnitude. And there's a chart example that we did for Longshaft so that we could correlate. So moving on to other kinds of incidents, I looked at the department, DMIRS website, and anyone can access it and look at the significant incident reports. And I'm concerned they show rock or backfill or water and miners doing what they naturally want to do. And the message I have for us today is that things done by accident, if we do things by accident, then accidents will result. And it's a sobering look at how easy it is for things to go wrong, and how studiously, religiously, we need to be doing our risk assessments and covering all our bases. So I'll just quickly run through a few incidents here. I wonder who remembers in 2006 a paste fill problem, paste wall failed, and there was an employee in a vehicle nearby who took steps to evacuate. That translates as probably breaking the speed limit in reverse in his vehicle. Another case in the same year, paced 1 metre high, escaped and flowed past a ute. Two Sparkies were there, and they survived getting onto the ute. In 2020, a paste-fill wall failed and 2 employees escaped. They had to climb up the mesh. These things do happen. We've had a good run, but we must be vigilant. What about this incident? Wonder who recalls coming across this one 2 years ago, a 13-metre deep sinkhole. Open stope below. Well, it turned out to be open. It was thought to be backfilled, but it wasn't. And an IT and an explosives truck down there in the hole. That'll be quite a complicated process for the rescue people to deal with that. Fortunately, 4 people were nearby, but nobody was in the vehicles or too close to that hole. And what about this one? 5 years ago, vehicle was reversing. Surveyor was backing up towards the stope, planning to do the CMS, expecting to see a chain and a sign across the drive, which is his normal place where he would stop and then set up the equipment. The sign wasn't there, the chain wasn't there. It's so simple. I wonder what we could have done to do things differently. And we all know that while this one turned out okay, we have had boggers that have actually gone into stopes, and the outcome's not been so fortunate. And then in this case, a large rock fell into the open stope and bounced off the rill. It's a common practice. We do bogging of the stope. The bogging advances, and as it advances, you move from diagram 1 there to diagram 2, and the rill ends up being well inside the stope, and one can easily imagine how a rock could fall off a wall and easily roll down that rill. And I wonder what we do about that. Do we have a bund at all if there's an operator there? It's a scary, potentially scary situation. And then in the database, you can find some rockfall incidents. There was the one in the air leg workings in 2006, 4 tonnes, not bolted. There's the one in 2009. Operator was past the last line of bolts. Just slip out to put the next bolt on the jumbo boom. And that was pretty sad, the outcome of that one. And then in 2014, a fall in an air leg heading. The ground was only partly supported at the time. Another problem outcome. And then what about this one? This is very recent. I think it's August 2020. This is a face. It's about 5 metres high. You can see the metre squares that have been marked up here, and at about the 5 metre mark, one can see there the structure, fairly flat subhorizontal structure, and you can see how rocks have been able to detach with that structure above, something else behind, and there they are at the base. We know, or from the report, that the geological structures were present. Mapping was infrequently done. Inspections were not often done, and this face had already been fairly difficult. A lot of rock had been scaled down. There's no mesh, and a couple of guys were down there at the bottom putting the lifter tubes in when the rocks fell. Fortunately, they survived. They were both okay, but it could have easily gone differently. So that's a few of the incidents, but here's 3 that are not in the DMIR database. This year we've had 3 inrush incidents at 3 mines in Western Australia. On 2 occasions I'm aware of, there were inflows through pit floor breakthroughs where stopes from underground had broken through into the floors of open pits intentionally. They're fired through, and you do get the voids. But as soon as you get those voids, you also get the possibility for water entry. And there was another case where the inflow came through ungrouted drill holes that connected the underground through to the surface, and the rock mass quality material was poor because it was weathered close to surface, and so the water was able to eat away to some extent at the drill hole walls, and so quite a lot of inflow came in. The photo you see there shows the level of mud that goes a couple of metres up the wall in one of the mines. The inflow came in, it was very substantial, and it made a huge flood going down the decline and leaving mud and also timbers and other kinds of rubbish scattered up and down the decline. What happened in that case is that the bunding around the surface rim of the open pit had been altered previously to permit some exploration drilling to be done near the crest, and so the bunding was unable to prevent water inflow. There's a lot of rain, not actually at the open pit, but in the general district, and it turned out to be a bit of a floodplain. The water came from somewhere else. The bunding wasn't in place, and it was a waterfall going down into the pit. We had that very high rainfall, generally in February, across the goldfields, and there were pathways to the underground. Now, in all cases, there were personnel underground. There were 2 or there were 8 underground who had to flee from the bottom part of the mine, and some of them had to make their way through the flood. So this is real. This is stuff that has happened in our state this year. Take-home message is this: mining done by accident will have accidents. We have to use design and method. We have to do our risk analysis to make sure that rock and waste and water and miners don't do what comes naturally. I'll use the illustration, as you see there, of the boomerang. Normally a piece of wood doesn't fly. If we were going to pick up a tree and throw it, it's not going to fly. It'll just land on your foot. But by using design and intelligence, we can make a piece of wood do what doesn't come naturally. It can fly. So likewise with mining, we're going to use intelligence, we're going to use design, we're going to use methods to make sure that the rock and the waste, the water and the miners do what we want them to do instead of what comes naturally. So may I encourage all of us to not go to sleep at the wheel, to do the risk assessments, to take those 5 minutes here, 10 minutes there, or 1 hour in the other place, to make sure that all our bases are covered, and so that we can have safe mining this year and every year. So thank you very much. Please get in contact on my email if you have any questions. Thank you.